quick demonstration of how the circuit works regards the switch. Okay, so at the moment I've got the circuit running at max cycle. I've got it on the higher setting, so that basically the switch works, it allows more energy to enter the circuit. So by using the switch you limit the energy entering the circuit. So at the moment this circuit is capable of around about 0.4 amps. Now this fan is quite a bit more than I expected actually. It's 0.2 on there, so I would say that's around about 0.16 amps, and on the back it actually says 0.018, so it's about 0.16, 0.17 actually that it draws from the power supply. Now if I reduce the speed of the circuit using my little pot down here, obviously you do this on your PC, there you go, that's my minimum there now. See, it's hardly dropped at all, and that's because the switch is in the high position and it allows a lot of energy into the circuit. So to get this realistically powered, I would knock it down to the middle setting. And now I've got 0.09 amps in the circuit. It includes 0.04 for the circuit here. So this is now running at 0.05, and as you can see it's running pretty slow. If I was to run it down to the small setting, which wouldn't be appropriate for this fan, it goes even slower again, goes down 0.07. So what I have to do in setting up, I would just choose which is more appropriate, the speed. Of course I could choose to have it on the high setting and just have maybe a 90% to 100% change in duty cycle, but I guess I'd say that would be around about 40% up to 100%. But obviously I still get the top end. There you go. So the top end is very slightly down on what it was full speed, but me talking half a volt, really very little. Put on the lower setting, this is a max speed, so you can see the fan is too powerful to the circuit, so it's drawn the voltage right down, so 0.14, 0.13. So I would say this fan needs to be on a medium setting. So we're back. This is a 120mm fan, rated at a very blurry 0.11 amps. And over on the display here I got 0.13, 0.14. This is in the high setting. Now I'll show again. I shall reduce the power to the petroleum circuit, and you see the fan has made no difference at all. So obviously I can't go in the high setting. The circuit back up and try the medium setting. Now again, let's not change all that much. As I crank the power down, there you go, it's gone down to 0.08. So the fan is now running quite slow, 600-700 RPM I would have thought. And then I can put it down to the low setting and it drops even further. And you can see that that's slower than you'd ever have it in your PC. But I can still increase in the speed. And there you go. So that's at the lower speed, very slightly underpowered. So that would be about 10.5 volts on this particular fan. So here we are, with a slightly banging cable. Here we are with an even slower fan. This is the Bitphoenix Spectre compared with the Spectre Pro I had on earlier. Now this is a 0.1 amp fan, which actually runs at about 0.07 amps, so it's quite a low power fan. This one is straight away running on low. Now this is what I've designed the low for. A number of my fans run at about this kind of current, so this is why I made the low setting for a single fan, that you could get full range of speed travel on there. So at the moment it's on max. I shall reduce it down to minimum, and there you go. So the fan is quite slow now. In fact, through the camera you can practically see it turning. It's not actually that slow, but anyway, so it's 0.06 amps, so that's running about 0.03 amps. That's 30% speed. I put it on the medium setting. It's basically running at about 60% just off the bat, and obviously in max it's just too much power going in there, and it's running at full at minimum duty cycle. So the low setting for that particular fan. And this is what happens if you put a fan on too low a setting. Oh, it's been helped by the wind. So that's just started up on the lower setting. This is it would start up, I mean, because PCs will start 100% for a few seconds and slow down. So this fan is barely turning over.